Is honey a natural superfood cure for type 2 diabetes, or just a golden sugar trap? Today, we unlock the deep cellular truth. Millions believe raw honey acts completely differently in the body than table sugar. But what does the latest medical science actually reveal? From how bees manufacture honey to why they ignore plant sweeteners like stevia, let's uncover every scientific secret right now. When a worker bee visits a flower, it extracts liquid nectar, a watery plant solution containing sucrose, water, and trace minerals. Bees store this nectar in a specialized organ called the honey stomach, keeping it strictly isolated from their own digestive system. Inside the crop, the bee secretes the enzyme invertase, which chemically breaks complex sucrose into simple glucose and fructose molecules. Back at the hive, bees pass nectar mouth to mouth, adding glucose oxidase enzyme generating trace hydrogen peroxide to destroy pathogens. To transform watery nectar into thick honey, bees rapidly fan their wings, evaporating water content from 80% down to under 18. Once dehydrated, bees seal the comb with airtight beeswax caps, creating a preserved, ultra-concentrated energy reserve for colony survival.
Honey's unique flavor comes from thousands of floral volatile compounds, essential oils, and organic acids specific to each flower species.
Chemically, pure honey consists of roughly 40% fructose, 30% glucose, 17% water, and trace bioactive polyphenols. Why don't honeybees harvest popular natural zero-calorie sweeteners like stevia, monk fruit, or allulose from nature? Because honeybees seek carbohydrate-rich nectar, and these sweeteners provide no calories. Steviosides and mogrosides are not present in flower nectar. They are complex defense molecules produced inside leaves and fruit tissue. Bees require immense metabolic energy to power their wing muscles. Non-caloric compounds offer zero usable fuel or ATP for the colony. Allulose is a rare sugar found only in tiny trace amounts in nature, far too scarce for bees to gather efficiently as a hive food source. Evolution dictated this alliance. Plants produce energy-dense carbohydrate nectar specifically to reward bees for spreading their pollen. Bee taste receptors are precisely tuned to detect high-calorie carbohydrates, completely ignoring non-nutritive plant defensive chemicals. Now that we know how bees manufacture this energy-dense food, how does honey interact with human metabolic health and diabetes? Upon ingestion, the glucose in honey rapidly enters the bloodstream, triggering an immediate surge of pancreatic insulin. Meanwhile, honey's 40% fructose travels straight to the liver, where excess amounts drive de novo lipogenesis and fatty liver. Honey has a slightly lower glycemic index around 55 compared to table sugar at 65, due to its higher ratio of fructose to glucose. Despite its natural origins, honey still imposes a heavy glycemic load, elevating blood sugar and exacerbating cellular insulin resistance. Clinical trials confirm that while raw honey offers micronutrients, regular consumption in diabetic patients still elevates overall HbA1c. Sugar is sugar to an overloaded liver, whether from a factory or a beehive. Professor Roy Taylor's breakthrough research proves that reversing type 2 diabetes requires stripping fat from the liver, something fructose opposes. Consuming honey daily without strict carbohydrate control keeps insulin levels elevated, preventing the body from burning stored body fat. Is honey a reliable treatment for diabetes? Medical consensus is definitive. No, honey is a natural sweetener, not a clinical treatment.
However, raw unpasteurized honey does contain propolis and antioxidants that reduce vascular oxidative stress slightly better than refined sugar.
Beware of commercial store honey, which is often heat processed or adulterated with corn syrup, stripping away beneficial floral enzymes. If substituting refined sugar for microdoses of raw honey, you gain trace bioactives, but overall daily carbohydrate limits must strictly remain. True diabetes reversal requires eliminating hyperinsulinemia through low-carb nutrition, intermittent fasting, and restoring cellular sensitivity. During active type 2 diabetes reversal, honey should be strictly minimized until metabolic flexibility and normal HbA1c are fully achieved. Understanding the exact biochemistry of honey empowers you to make evidence-based choices for your long-term metabolic health. Nature crafted honey as high-energy bee fuel, not a therapeutic diabetes cure. Respect its biology to safeguard your insulin sensitivity.
Subscribe to the channel Nutrition Dynamics
press the bell icon, and share it with your friends to spread useful information.